Hello everyone, I am Kanchana working in SNS College of Engineering as an assistant professor in the Department of Chemistry. In this video now I am going to say about synthesis of nanomaterials. There are two types, top-down process and bottom-up process. Chemical vapor deposition. Chemical vapor deposition involves the dissociation and or chemical reaction of gaseous reactants in an activated heat, light, plasma environment followed by the formation of a stable solid product. The formation of soot due to incomplete oxidation of firewood since times is probably the oldest example of deposition using chemical vapor deposition. Patent literature by Lodingu in 1893 on the deposition of W onto carbon lamp filaments through the reduction of hydrogen lead to the industrial exploitation of chemical vapor deposition. Chemical vapor deposition is a process whereby a solid material is deposited from vapor by a chemical reaction occurring on or in the vicinity of normally heated substrate surface. The solid material is obtained as coating, a powder, or a single crystals. By varying the experimental condition substrate material, substrate temperature, composition of the reaction gas mixture, total pressure gas, flows, etc. Materials with different properties can be grown. Chemical vapor deposition is an example for solid vapor reaction. Main components of CVD equipment: carrier gas, evaporator, reactive gas, oven, pump, and substrate. Main components of CVD equipment: chemical vapor precursor supply system. The role of this component is to generate vapor precursors and then deliver to the reactor. The design of the chemical vapor deposition reactor depends on whether the starting material is solid, liquid, or gas. The sublimation of solid precursor depends on the surface area of the solid and contact time. Liquid sources often use a bubbler to vaporize the reactants and carrier reactive gases such as hydrogen or inert gas such as argon to transport the vaporized reactants into the reactor. And another one, CVD reactor. Hot wall reactor and cold wall reactor. There are two types. Hot wall reactor. In this substrate, wafer and the walls of reactor are heated. For example, homogeneous temperature is maintained inside the reaction chamber. Disadvantage of the hot wall reactor is contamination. Cold wall reactor. This reactor uses heating system that minimize the heating up of the reactor walls while the wafer is being heated up. The temperature is not homogeneous inside the reaction chamber. Disadvantage of cold wall reactor: it is difficult to get uniform layer of the film. This is diagrammatic representation of hot wall tube and cold wall chamber. And another one, the fluent gas handling system. This component consists of neutralizing part for the exact gases and or vacuum system to provide the required reduced pressure for the CVD process that performs at low pressure or high vacuum during deposition. The unreacted precursors and corrosive byproducts such as HCl are neutralized or trapped using a liquid nitrogen trap. Inflammable gases such as hydrogen are burned off. Unreacted expensive precursor may be collected at the outlet and then recycled. In a typical chemical vapor deposition process, the substrate is exposed to one or more volatile precursor which react and decompose on the substrate surface to produce the desired deposit. During this process, volatile byproducts are also produced, which are removed by gas flow through the reaction chamber. Steps involved in chemical vapor deposition: transport of reactants by forced convection to the deposition region, transport of reactants by diffusion from the main gas stream to the substrate surface, adsorption of reactants in the substrate wafer surface, chemical decomposition and other surface reaction takes place, and transport and desorption of byproducts from the surface, transport of byproducts by diffusion, transport of byproducts by forced convection away from the deposition region. These are mechanism of chemical vapor deposition, main gas flow and gas phase reaction, and desorption of precursor and desorption of volatile surface reaction products, and step growth, adsorption film precursor, nucleation and island growth. There are five types of chemical vapor deposition involved here. First one is low pressure chemical vapor deposition, metal organic chemical vapor deposition, photon induced chemical vapor deposition, and plasma enhanced chemical vapor deposition, and atmospheric pressure chemical vapor deposition. Um, Thank you all.